Right, so let's go to the next problem. It is this. Okay, so what is given? X1 of t has x1 of j omega and x2 of t has x2 of j omega as the Fourier transforms. Okay, and the product of x1 and x2 is passed through an LTA system with impulse response h of t equal to e power minus 2 mod t. So question is, what is the minimum sampling rate required to sample y of t? Okay, right, so let me say that this is some a. Okay, so at a, what will happen to the Fourier transform? Okay, so what is happening here? So at a, x1 of t and x2 of t are multiplied. So what should happen in frequency domain? These two functions corresponding Fourier transform should get convolved. Okay, so these two fellows should get convolved, and this will give you the Fourier transform at a. So how does the plot look? The Fourier transform plot. So these two fellows are, after convolution, they will have some funny shape, and but that shape exists from where to where? That shape exists from where to where here? That shape exists from minus b1 minus b2 minus b1 minus b2 to b1 plus b2. Amplitude we are not concerned because we are talking about sampling rate. So whatever may be the amplitude, it doesn't matter. Okay, so the Fourier transform at a will look like this, and that is passed through an LTA system with impulse response h of t. So what should happen? Because it is passed through LTA system, the corresponding Fourier transforms should get multiplied. Okay, so I will write down that h of t equal to e power minus 2 mod t. So this fellow will have what as Fourier transform? H of j omega, which is equal to 4 by a square is 2 square, which is equal to 4. So 4 by 4 plus omega square. H of j omega would be 4 by 4 plus omega squared. So what should happen? And this fellow exists from where to where? From minus infinity to plus infinity. So let us try to plot that. Our h of j omega. Okay, so h of j omega, the plot will look like this. Okay, so why? When omega increases, denominator increases, and hence the overall Fourier transform goes on decreasing. It's not Gaussian, but it looks like a Gaussian. So the Fourier transform at a and h of j omega, these two fellows should get multiplied. So after multiplication, what happens? The overall product will give you Fourier transform. So overall product will give you Fourier transform of y of t, which is y of j omega. So after multiplication, again you have a nice funny shape. So that funny shape exists from where to where? Minus b1 minus b2 to b1 plus b2. Okay, so what is the highest frequency here? Highest frequency is b1 plus b2, and hence what will happen to the sampling rate? That should be 2 times b1 plus b2. Okay, we'll write down that. So highest frequency. Okay, so highest frequency of y of j omega is equal to how much? b1 plus b2. Okay, so that is radians per second. That's okay. Okay, so and this implies minimum sampling rate. Okay, so minimum sampling rate should be equal to how much? 2 times of b1 plus b2. Okay, so in this problem the units are not properly given, but yeah, so intuitively you can say that 2 times b1 plus b2 is the sampling rate. Okay.